Okay, let me solve. So I discussed that uh, delta L is equal to 4PL upon pi d1 d2 e. That is the elongation in tapered bar. I hope you remember, just I discussed right now also. Suppose you apply P load here and P load here. D1 is here, D2 is here, and E is given modulus of elasticity. So delta L elongation in length is this. And you also know delta L is equal to L alpha delta T. Now equate both the equations, you can get 4PL upon pi d1 d2e is equal to L alpha delta T. Now subtract, cut out L, you can get T, the reaction force at the end, alpha delta T pi d1 d2e upon 4. Okay, up to here, it is the reaction force. Reaction force means, suppose because we increase the temperature by 30 degrees Celsius, then it will try to elongate along the length. And you put a constant that it should not elongate. Then what will happen? A reaction force, a compressive reaction force, is acting at the ends to prevent its elongation. Okay. Now this is the P force, and it asks what is the maximum stress induced in the bar. Now you have P force at this end and P force at this end. So in the entire section, you have a P compressive reaction force. Now you have to find out stress, and stress maximum should be where the area is minimum. Now, can you find out where the area is minimum? This is D1 and this is D2. You can see that here the area is large, here the area is the smallest one, this is the largest one, and in between, it is in between D1 and D2. Therefore sigma max is equal to P upon pi by 4 D1 square. Okay, so in this part, just if you just divide P by pi by 4 D1 square, and also right hand side you can divide this pi d1 d2 e upon 4 into pi by 4 d1 square. So this will cut out, and you get alpha delta t d2 e upon d1. So this is sigma maximum in the bar, alpha delta t d2 e upon d1. So your answer will be, I'm just telling the answer, 76.8 megapascal. Okay, so any problem? I hope you get it. Shall I move ahead? Hello, anyone please? Is it okay?
Sir, 1 minute, sir.
Okay. You want to write? Okay. Okay, I'm moving ahead now. If you want, you can take a screenshot. Uh, so the next,
Sir,
yeah,
the answer is 76.8 or 768, sir.
it's megapascal. You might miss something in the unit. Please check it.
Okay.
If not, let me see. If not, the process is same. If you got getting any error, then it should be in the value or in the unit. Okay.
Okay, so I'll check it later.
Okay. Now, second question is, given it is a sample of a metal is under tension, tested under tension, and it is given that uh, at stress of 450 Newton per mm square, the strain is 0.0080, and on the removal of this stress, means when sigma becomes 0, when I remove this stress, there is a permanent deformation, and its value is E permanent. If I write, it is 0.0015. Then we have to find the modulus of elasticity for that metal. So let me draw this in figure. Suppose this is your stress strain diagram, and it is given that you are testing a metal under tension, and up to this point it is tested, and here the strain is 0.0080, and the stress is 450 Newton per mm square. Now, if you just release the stress and it is coming back to the position, it has a permanent deformation. And what is the permanent deformation? This value. This value is 0.0015. Then you have to find the modulus of elasticity. So you know stress is equal to epsilon into elasticity. This is up to Hooke's law. But here it is given that it is elastically deformed up to plastic region, and there is a permanent deformation for the metal. So I told you, just remember that if it is coming along the along the same length, because of the permanent deformation, the elasticity of this and the means the slope both are equal. Why? Because now the material is permanently elongated, but the elasticity will not change. So if I write equation of line between the point A and the point B, what will be? This is it. What is the slope? Suppose tan theta that is equal to E. What is the slope? Uh, sigma minus sigma A minus sigma B upon epsilon A minus epsilon B. This is tan theta. This is the equation of line that is equal to E. Now, if I write it here, tan theta is equal to E is equal to sigma A, it is given 450, and sigma B it is 0, because here the stress is 0, but there is strain. And what is sigma A or epsilon A? Epsilon A is given 0.0080, and what is epsilon B? 0.0015. So what the value of E is, you can solve this and you can just answer me what is the value coming.
69 gigapascal, sir.
Okay, 69 gigapascal. So I'm not doing it. You can check it is right or wrong. So you can say I think in 2020 gate, this type of question is asked. 2020 gate, this question is asked, or in 21, maybe in both years, in any of the both years, it has been asked. Now another question I'm going with. Okay, suppose Mohr circle is given. Okay, and the Mohr circle is given a circle of 2 megapascal. The radius is 2 megapascal, and you have given four options. 1 megapascal shear stress, 2 megapascal here, 2 megapascal shear stress, and a body of 1 megapascal. So, what is the correct representation of the stresses? If the mode circle is given, a circle of radius 2 megapascal and centered at origin. Um, Anyone can reply? Oh, sorry. This will be. So, any answer? You can write in the chat also. I hope you understand the question. This is the mode circle given for a shear stress and normal stress problem. So, what is the correct representation of that body, the foot, the action of stresses? So, can you tell A, B, C, D which option is right? Hello, am I audible? Hello, hello.
So audible, sir.
Okay, B option is right. Okay, let me try to solve it for every problem. So, if I draw more circle for this, okay, it is given 1 megapascal in every direction. So, if 1 megapascal in every direction, so sigma is equal to 0. So, 1 megapascal in positive, 1 megapascal in negative. And if you draw that a circle, it is circle with a radius of 1 megapascal. So, this cannot be the answer. Now, if you consider this B portion, and it is given 2 megapascal and both are tensile, so 2 megapascal, and it will denote a point because both points sigma 1 and sigma 2 both lie here only, so it will be a point. Now for this condition, if you see, it is given 2 megapascal. Now 2 megapascal upward and 2 megapascal downward. Now, some people can ask why, sir, both at different position, and for here you are putting it in single location. So, if you look at it, it is a clockwise moment, so it is positive, and it is an anti-clockwise moment, so it is putting on the negative tau axis. Now, if I join that, it will be 2 megapascal. The radius is 2 megapascal. So, the correct option is C. And for D, it will again a point. Okay. So, it will again a point. So, any problem in this question? Hello.
No, sir.
Okay. Now, last time there were 25 participants. Why 22 participants? Why today very less? I don't know. Okay, I'm going with next question. So now going with bending stress diagram and bending moment diagram. Now shear stress and bending moment diagram. Suppose a load is given. The load is, if you see, This is a load, sorry, beam. This is the reaction support. And now you have a load of 5 kilonewton at this point. In this, suppose a L shape is produced at the L shape, and the top of it a 5 kilonewton load is acting. This is 2 meter. This is 1 meter, and this is also 3 meter. So this is point A, this is point B. So you have to ask that draw the bending moment diagram for the beam. So I just find the reaction force. So what is the reaction force at RA and RB? Now RA into, if we take moment about B and equate it to 0, then RA into 3 to 5 into 6 is equal to 5 into, that is 3. Then RA will be 15 by 6, or 5 by 2, 2.5 kilonewton. Is it okay? Now RB will be, because it is 5 kilonewton, so RB will also be a 2.5 kilonewton. Okay. Now we have to draw the bending moment diagram. So let's first draw the free body diagram. This is 2.5 kilonewton. This is also 2.5 kilonewton, and up to here it is 2 meter. It is given 1 meter up to here, and after that 3 meter. And now just it is 5 kilonewton load is acting. Now suppose if you want to transfer this load at this point, then take suppose I want to put this load at this point, act this opposite load here also. Suppose if I act load at the top and also the bottom, there is no effect. Now this load and this load will form a couple. If you see it, it form a couple, and the this P load is transferred at this point. So if we just try to equate it, the load 5 kilonewton is acting, and also a couple in the anti-clockwise direction, sorry, in the clockwise direction at this point is acting of 5 kilonewton meter. Up to here, any problem? Okay. Now I have to draw the bending moment diagram. So before it 2.5, it is a linear load, because as you can see, if you take any moment at this point, it is m is equal to 2.5 into x. So will be a straight line up to 2 meter. Up to 2 meter, it will be a straight line. Now this moment and this 5 kilonewton meter will add up. And now if you take at this point load, 2.5 into 2 plus, because it is also acting in clockwise direction, and this load is also, this couple is also acting in clockwise direction. So plus 5, it will be 10 kilonewton meter. So that will shoot up, suppose up to here, it will be 5 kilonewton meter. Now at this point, it will shoot to 10 kilonewton meter. And after that, 5 kilonewton meter is also acting in the downward direction. So take at this point x. Okay. Now it will be m is equal to 2.5 into 3 plus x at this point. I'm taking at this point 2.5 into 3 plus x plus the couple. For the couple, there will be no any distance. So because it is acting means only, because couple will add up as simple as it is, minus 5 into 1 plus x. Now if you solve this, if you solve this, the load will come like this, gradually decreasing up to, sorry, it will come like this up to point B. Okay, so this is the bending moment diagram for this kind of stress. So uh, any question in this any question, any confusion related to this diagram? Can anyone write in chat box, or I will move ahead? Okay, I will explain. Look, in if you see that, so if you see that the load is acting at some distance from this axis. Now, if I want to transform at this point, what I have to do is, uh, I will act. Suppose this is your L shape. This is acting 5 kilonewton. Now I will add 5 kilonewton here and also 5 kilonewton here. No change in the system. You can see that the body will remain as equivalent to 5 kilonewton only. It will cancel out. Now you can see that this load and this load is forming a couple in this direction, and the distance between them is 1 meter. So if I and this load will shift to at this point because the load acting along the same axis will shift. So you can see that now this 5 kilonewton, I will transform the system in this way. Now the S shape I can remove this, and at the beam there is a 5 kilonewton load, and also this couple. You can see that this is 5 kilonewton meter is acting. So I transform this load in this way. Now the reaction part, it is easy, 2.5 kilonewton and 2.5 kilonewton. So if I want to draw the again the shear stress diagram, let me draw it. Suppose this is your beam, it is acting by 2.5 kilonewton and 2.5 kilonewton, and at 2 meter, 5 kilonewton load is acting, and a clockwise moment is acting 5 kilonewton meter. So if I draw the bending moment diagram up to 2, suppose this is section xx dash. So at xx dash, moment is equal to 2.5 into x. Now this is a linear function of x, so it will be a straight line up to 2 meter, because after that another couple is acting. Now if I take at this point, then at 1 meter, means sorry, at 2 meter. If I take at this point, then the mx will be 2.5 into 2 plus 5, then it will be 10. So at this point, you have a 5 kilonewton. Now it will shift to 10 kilonewton meter. And after that, if you take any other position, suppose x, from I can say here. So suppose I can take x from here. So m is equal to 2.5 into that. This is 2 meter and this is x. 2 plus x plus 5. This is for the couple, and minus 5 into x. So if you solve it, it will be 5 plus 2.5x plus 5 minus 5x. So it will be 10 minus 2.5x. Then it will go like this. If you draw it, it will go like this. Okay? Because at x is equal to 0, the couple is 10. So the 10 is coming, and as you go on increasing along the x, it will decrease, and at x is equal to 4, you can see that uh, at x is equal to 4, 2.5 or 4 into 4 is equal to 10. At end point it is 0. So you can see the bending moment diagram now. So are you clear? Who asked the question? Uh, okay. So one question from shear force and bending moment diagram, and now I will start. Any question? Okay. Now I will start new topics here. Bending stresses and shear stresses. Let me solve one more question. I have time. Okay, I will move ahead. I I will solve it later. Part. So everyone with the syllabus, I hope understand. So concept of pure bending. So in concept of pure bending, let me show example. Suppose this is a beam and you apply a moment like this. Then if you draw the shear force diagram, this suppose this is the reaction here and here. The reaction for the shear force diagram will be zero along the axis, but the bending moment diagram is positive m along the whole axis. So this is the case of pure bending, where there is no shear force SFD, and where is this BMD, bending moment diagram, and this is positive m along the length. Now suppose if I take another part, R1, R2, suppose this is 2 kilonewton, this is 2 kilonewton, this is 2, this is 2, this is 2, 2 meter length. Okay. Now, if what is the reaction force? You can see by symmetry, R1 equal to R2 equal to 2 kilonewton. I hope everyone know how to find the action force, because this is a concept of mechanics. Now, if I want to draw the shear force diagram, what will be the shear force diagram? Up to here, it is 2 kilonewton, gradually 2 kilonewton constant. Then here 2 kilonewton is acting in the downward direction, so it will come to 0. Okay. Up to that, it will be 0 for the next 1 meter. Then it will go like this. So this is this state, this portion, we can say this is the B is in pure bending. Means wherever the shear stress is 0, you can say the beam is in pure bending. Okay. So now in pure bending, you can see that in pure bending, I hope you all remember, there is a flexure formula, that is m by I is equal to sigma by y is equal to E by R. I am not getting with the derivation because you can see it in any book, but I am going with the concept of how that is coming. Now, suppose if I apply a load, suppose there is a beam, and a load and a couple is acting like this. So it will deform like in this shape, if you can see it. Now, if is any body deformed like this, it is called hogging. And if any body deformed like this, it is called sagging. Okay, just wait a sec. Oh, I just said opposite. That's what. Sorry. If I just erase it, Okay. Now this is called the sagging and this is called the hogging. It is the opposite. I just got it wrong. So this is the in the pending. Now if I just you want to emphasize that you can see that this bottom fiber is elongating and this top fiber is compressing. If you can see, this top fiber is compressing and this bottom fiber is elongating. Means this bottom fiber is in tensile stress and this top fiber is in compressive stress. Compressive stress. Now, if you see in the hogging, you can see that this part is elongating much, and it means this part is in tensile because of elongation, and this part is in compression. Now, so means suppose if I want look at here, this is the top fiber and this is the bottom fiber. Fiber means plane. You can see that this is a plane. I am saying fiber. So if it is compressive. Compressing means it is shortening and it is elongating. So in between this plane, there must be a point where the value is zero, means that will be neither elongating nor compressing, because if something is positive and something is negative and for a continuous thing, there must be a zero in between. And the plane where there is no elongation, no compression is called the neutral plane. This is called the neutral plane. Means neutral plane is the plane where there is no elongation and no compression, because the bottom portion is elongating and the upper portion is compressing or shortening. So in between that, there need to be a such value which is zero, and for that zero value, the plane passing through the point is called neutral plane. So in bending stress, neutral plane is very important because neutral plane helps. Suppose this is a cross section of this beam. So suppose this is a neutral plane. If you cut it like whole, so neutral plane. If I like it NP, so the moment of inertia need to be obtained along the neutral plane only. Okay. So that's why the concept of neutral plane is important. And you can see that at neutral plane, there is no elongation, no compression. And if there is no elongation, no compression, there is no stress, no bending stress. Let me like it to be precise, no bending stress. Okay. So I am going with the Flexner formula. So this is also called bending formula. It is called sigma by I, sorry, sigma by y is equal to E by I is equal to M by I. Now, every sentence has meaning. What is sigma? Sigma is called the bending stress. Y is the distance from the neutral axis. Distance from neutral axis. Okay, for which fiber we want to obtain the means what bending stress, that is a distance. E is the modulus of elasticity. R is radius of the shape of the beam. Suppose a beam is formed in this way, so complete a circle, and this is the radius. This is the radius that I am talking about. M. M is the moment acting at this point. We can say that at that point, what is the bending moment diagram? bending moment at the point. And what is I? I is the moment of inertia at neutral axis. So how bending stress is generated? That's why I asked shear stress and bending moment revision. Shear force diagram and bending moment diagram. Why I revised that? Because you can see, I just told you in previous lecture, they are the internal resisting force and couple. And these internal resisting force and couple will would lead to stress. Hence, bending moment leads to bending stress and shear force leads to shear stress. That's why I just draw it right now so that I can make you understand in a more precise way. So suppose first bending stress for symmetrical sections. Any problem up to this point? Just please unmute yourself. Hello, hello. Just can you check, write in chat box or speak?
Clear, sir.
Okay. Now, uh, so let me give you something. So what is the meaning? Suppose I have a beam. Okay, simply supported beam, and I put a load W at it. And if you look it from this side, suppose this is your eye, and you are looking it from here. Okay, from here. So the cross section is a rectangular cross section of B width and H height. Okay, and this is L. So viewing from here, you can see that this is your cross section, means a rectangular bar, you can say in general. So let me write it in a 3D version. So now I know you can get it. This is B and this is H. And I put a load W. So what is the shear force if I draw? It will be like this. And bending moment, it will be like this. Okay, this is. Now I want to find out the bending moment at this point. Suppose I want to find out bending moment at this point A. The bending moment at this point is A is, it is given W L by 4. It is W by 2 into L by 2 W L by 4. Okay. Now what is the bending stress at point A? At sigma at A, what is the bending stress? We need to find. Now using the flexor formula, what is the meaning of that? Sigma by Y is equal to E by R is equal to M by I. Now you can see that you cannot use E by R because neither E is given nor R is given. So you relate these two activities. Sigma by Y is equal to M by I because you know M at this point, the point of the location, that is WL by 4. You know I, you can obtain I at this point. Okay. And you can also obtain Y at the location. So let me like it, sigma is equal to my by I. Now, and what is the moment at the point A? Now, at the point A, what is the moment? It is WL by 4. What is the distance of Y? It is H by 2. And what is I? I should be about the neutral plane. And what is the You know, the neutral plane for a regular section is passing through the center of gravity. For symmetrical sections, center of gravity. For symmetrical sections. Symmetrical means normal, rectangle, square, circle, triangle. Everything is passing through the center of gravity. So the center of gravity for a rectangle is it's h by 2. So what is the I for at the neutral plane? I is equal to b into h cube by 12. So I write b into h cube by 12. Now, what is the value of y? Y is the distance from the neutral plane at which point we need to obtain. So if I just write this is the neutral plane. So this is your neutral plane. Now the distance from this is h by 2. Okay, this is your height. So if you can see this is h by 2. So it is h, sorry, I had written it is h by 2. Okay, okay. Now sigma at point A. Now if you need to obtain a sigma at point B, what is sigma at point B? Sigma at point B, same thing. Moment, what will the moment? WL by 4. The distance from the neutral plane of the bottom fiber, it is y by, it is h by 2. And what is the I about the neutral plane? It is bh cube by 12. So you can see the both values are coming equal. So what is the difference between A and B? Now if you can see this beam will act form like this. Hence, this top portion is in compression and this bottom portion is in tension. So at B it is positive and at A it is negative. Means it is compressive and at B it is tensile. I hope everyone is okay with it. Hello. You can draw it, write it, and if any problem, ask it. You can. Hello. Okay. Now I am going with the symmetrical sections. So can suppose I have a beam, same beam, the load that is active and W. Now what is the sections? Sections means the base area that is elongated. Means what if I look at from here in 3D position? What is the section? So the sections can be rectangle, square, triangle, circle. Okay, these are the regular sections or regular figures that can be used. Now if I take this rectangle and for the same load, the sections is rectangle, this is square, this is triangle, this is circle. Now if this is B, this is H, just right, I just added at this point and I want to find out the bending stress at this point. The bending stress will be sigma is equal to m into h by 2 upon I. Now for the what is the I? I is bh cube by 12 and the your is like W load is acting, it is WL by 4. Now for square h is equal to B. So sigma is equal to WL by 4 into h by 2 upon B would be h into h cube by 12. This is for square. Now for triangle. For triangle, you know that their center of gravity is 2h by 3 from the top and h by 3 from the bottom. So now if if a beam is drawn like this way and their cross section is a triangle, so you cannot say that at this point and at this point their stresses are same. Now how? Let me explain. Suppose this is your neutral plane. Okay. uh, so this is your beam, this is your cross section, and a W load is acting. So at the center, I want to find at A and at B. At the center, what is the moment? W into L by 4. So sigma at A is equal to WL by 4 into what is now Y. From the neutral plane, the top is at 2h by 3. So it is 2h by 3 divided by I. I for the triangle, if this is B and this is H, for the triangle it is BH cube by 36 along the uh, its center of gravity. Now sigma at B at this point, what is the bending stress? It is WL by 4 into, now the value of the bottom fiber is H by 3 and divided by BH cube by 36. So you can see that sigma at A divided by sigma at B is not equal to 1 in this case. Okay, means I want you to just lead to a conclusion. What is the conclusion? Let me write. The conclusion is sigma is directly proportional to y. As you can see in triangle, the top fiber is much away more distance. It is 2h by 3 and it is h by 3. That means for a cross section, suppose this is a cross section, and if I want to draw the bending stress, then at y is equal to 0 means at the neutral plane it should be 0, and above it is increasing and below it is increasing. Now why I draw like this? Because if this is tensile, then this should be compressive, and if this is compressive, this should be tensile. For so as y increases, sigma increases, and this is your profile for bending stress. Bending stress. So any problem with the with what I explained? Any question? Just write in the chat box, because this is difficult to go with online teaching. In hello, anyone can just write. Okay, now for the circle that I want to write. For the circle, this is a regular section. So W node is acting. Now sigma at point A. Suppose this is point A and this is point B. Sigma at point A would be m into what is the value of y? It is r by, sorry, it is r, or I should write it as a d by 2 upon, because the top fiber is at distance from the neutral axis r, that is equal to d by 2, divided by the moment of inertia at the from the neutral axis. What is the moment of inertia? It is pi by 64 d raised to the power 4. Now sigma at b, it is m into d by 2 upon pi by 64 d raised to the power 4. So both are equal, but as you can see, the profile will be like this. So the top fiber is in compression nature and the bottom fiber is in tensile nature. So you can get this from the basic equations. Now some question related to questions for bending stresses. So I'm going to some write a question. So, okay, just give me a sec. So it is given uh, a steel wire of 5 mm dia is bent into a circular shape of radius 5 meter. Given E is equal to 200 gigapascal, what is the maximum stress induced in the bar? Okay, maximum stress, that is bending stress induced in the bar. So I'm giving you 1 minute just to think about it, then I will explain. And please respond in chat box. Just type it. It is not a classroom. In- If you are getting anything, not getting anything, I am here to explain you know. So don't worry about it. Okay, I'm going to explain. So it is given that uh, let me go. So it is given that a wire is bent in the form of a circle. Okay. Yeah, it is 100 Newton per. Please check with the units. It is 100 Newton per mm square. It should be. Please check with the units. Okay. Now the wire is bent in the form of circle and given radius. Now uh, this radius is given 5. This thickness is given 5 mm. Now, what will be the maximum bending stress? So, write the flexor formula. Sigma upon y is equal to E by R is equal to M by I. Now, you don't know M, you don't know I. You can know I, but you don't know M. So, you have to go with these two equations because you know E. Sigma by y is equal to E by R. Now, that is equal to sigma E into y by R. Now, the radius is given 5 meter. So if you write it like this, sigma is equal to E into the radius should be for the neutral plane. It should not be 5. It should be E into 5 plus 0.005 by 2. It should be this value up to the neutral plane. Okay. And what should be the value? Sorry, I just write it opposite. R should be 5 plus 0.005 divided by 2. And what is the maximum value of the y? Maximum value of the y is the radius of the wire. Radius of wire. So if you write it like it, sigma is equal to E, it is given 200. So change into megapascal into 10 to the power 3. Radius of the wire, it is given 5 mm. And what the diameter, the wire, the circle radius is 5 meter. Let me write in mm plus 5. And you can see that in 5000 this 5 value is very small. So if you just remove it, it will not affect much. So divide it like this, it is 1000, and you cut it, uh, it is coming, sorry, there is something should be wrong, sorry, 5 meter radius, 5, oh, I got wrong. Y should be 5 by 2, it is 100. So it is 100 Newton per mm square. I am seeing someone is getting 100 Newton per meter square. No, it should be or 100 megapascal. 100 megapascal. So please correct the thing. Are you okay with it?
Yes, sir.
Okay. So now just so suppose I am giving you a question. This is a section of a beam simply supported of load P is equal to 5 kilonewton. E is given 200 gigapascal and length is given 2 meter. Now you have to obtain at this point A, what is the bending stress? How I have given everything. No, it is 2 meter. Sorry, 20 mm by 20 mm. I think it is very small, 20 mm by 20 mm. Let me change to 50 mm by 50 mm. 50 mm by 50 mm. Now you need to obtain the bending stress, and for the same question, for the same figure, now the cross section is changed to this one. Means it is a square, but it is now at point at its edges. Means you can see it like a square has been rotated along this axis. So if you rotate this, it is also 50 by 50. But now for this, you have to obtain the bending stress at point A. This is the cross section. First, the cross section is this, and now cross section is this. So I am giving you 1 minute. Just think about it. Use the formula sigma is equal to my by I. Okay. To use this formula, I am giving you just 1 minute. Please think. Okay. I'm going to explain how I'm going to do. So first, Take this cross section. I just explained. Take the neutral plane. The maximum distance is 50 by 2, and the I would be dh cube by 12, or you can say h to the power 4 by 12. Okay. Now you can simply obtain at the for a square. It will be, sorry, what is the value of this? 5. Okay. Just write it, 5 into 10 to the power 5 Newton into y, it would be 25 divided by I, s to the power 4, that means 50 raised to the power 4 by 12. That is the value in megapascal. Okay. Now, why I done this question, I'm not going to explain the calculation, I'm going to explain the concept. So, if the square is positioned in this way and the non-neutral plane would be like this, so can anyone say what is the I of a square about the neutral plane? What is the value? Just any guesses, unmute yourself and say, because that's why I given this question. It is because of this part. If you don't know, also say I don't know, sir, because that's why I given. If you know, then speak. Hello, please say something. Hello, am I audible? Hello. If you don't know, also write, sir, I don't know. It is not, there is no anything, I will explain, but say something. That's why I'm asking. Okay, I don't, not getting any response, so I'm writing here. Why 50 is the power 36? Uh, is just someone say you have, I hope you understand in mechanics, moment of inertia. I hope you studied that part. Just say yes, sir, I studied that part. If the person has taught you, or the faculty, whoever has come, moment of inertia. Yes, sir. Okay. Then still you're not able to solve. That is because let this is a mechanics portion, and I need to prove that it is not like that. It is not 50 ki power 4 by 36. Why? Let me show. So please consider it. Yeah, 50 ki power 4 by 12. Okay. Now why I will explain, because suppose this is your square. Okay. What will be the it lying in the horizontal position, and this is your n dash. What is the I about n dash? Everyone knows. It is h to the power 4 by 12. Okay. Now, what is, suppose I change it. It is m dash. What is I m dash? It is also h to the power 4 by 12 because it is square. There is no change. Okay. Now, I hope you know the theorem of perpendicular axis in mechanics. Izz is equal to Ixx plus Iyy. Now, if this is equal, that means suppose this is x, this is y, and perpendicular to this is z. So Izz is equal to Ixx plus Iyy. And now, if I rotate this, sorry, okay, this is your x-axis, this is your y-axis, and this is your z-axis. Now, in that case, because of symmetry, you can see that Ixx is equal to Iyy. You can see that if any question, any doubt, you can ask. But you can see that because of the symmetry, diagonal lengths are equal, all sides are equal. Hence, if you rotate it any times, ixx should be iyy. Okay. Now, if I and perpendicular to the z, you can write here also izz is equal to ixx plus iyy. Because it is the same figure, so izz would be same. Now put that izz dash is equal to izz. You can see that here h to the power 4 by 12 into 2 times is equal to ixx plus iyy. This question has came from here. Now you can see that ixx is equal to iyy. So I can write it 2 times ixx is equal to 2 times h to the power 4 by 12. I end up cutting this and I got xx is equal to h to the power 4 by 12. So you if you rotate the square, the value of I it would be h to the power 4 by 12. That's why I have given this part. Okay, it is h to the power 4 by 12, same as the earlier one. But what will be the change? The change would occur in the distance of y, because now y would be 550 root 2 by 2, because the complete is the diagonal length and it is half. So diagonal length will be 50 root 2 and it is divided by 2. So now if you write sigma, then it would be m, that is wl by 4, wl by 4 into 50 root 2 by 2 upon h to the power 4 by 12. Okay, here there is a misconception. This is 50 into 10 to the power 3 into 2 by 4 into 1000. Hello. Anyone has now cleared the concept of changing the orientation, or someone has any problem? Okay. One who got value 50 to the power 4 divided by 36, is it clear? Someone, oh, yes, good, good. So that's why I given the question. Now the next question is, uh, same square beam. I am giving the same square beam, and now it is loaded UDL, and UDL of let me write the value of UDL. Okay, no, it is not a square, it is rectangular. Okay. It is rectangular. It is 60 mm and it is 150 mm. The loads same roller support, pin support, and it is 4.5 kilonewton per meter. Given that this is 4 meter. Now you have to obtain the maximum bending stress. Maximum bending stress. Sigma bending. So just 1 minute, think about it, then I will explain. There is no any point given. It is given obtain the maximum bending stress. No any point is given. So you need to find where the maximum bending stress, maximum bending moment is acting, and then after you have to find out where the maximum bending stress is acting. Just think about it. I'm giving you 1 minute. Okay, let me explain. So it is given, you need to find maximum bending stress. First of all, just go with the basic. It is my by I. Now, you need to find, so I would be constant. You know, I about this axis would be constant. 150 raised to the power 3 into 60 by 12. This is I. And this is constant. Okay, don't worry about it. You need to find the maximum value of M and maximum value of Y. Both should be maximum, then it will be maximum. Na? Otherwise, it will not be. So, first of all, draw the bending moment diagram. And for that, obtain the reaction support. So, this is, suppose this is point A, this is point B. So at point A and point B, what is the reactions? If you see that the reaction RA is equal to, uh, I think it is 9 kilonewton. It is also 9 kilonewton. Can anyone confirm it is okay? Okay, it is 9. Now, if you draw the bending moment diagram, what is the bending moment diagram for it? I hope everyone remembers it. It will be a parabolic in shape. This is point A and this is point B. And from the bending moment diagram, you can see that the maximum bending moment is obtaining at the center, and its value is WL square by 8. Okay, this is small w. This is the maximum bending moment. So therefore, first part need to be clear. The M has obtained and its location is, that is at the center. The maximum bending moment is WL square by 8. So M max is equal to WL square by 8. So W is 4.5, 4.5 into 10 raised to the power 3 into L square. What is the value of L? L is 4, 4 square divided by 8. So this is your maximum bending moment. Now you need to distance, equate the distance y, because at the center, this is the thickness. So you as you all know, the bending stress would be like this. This is your shape or profile of the bending stress. So at the center, at this point and at this line, the variation is there. So at the top fiber and at the bottom fiber, the maximum stress is there. So Y should be H by 2. That is 150 by 2. Now sigma max would be M max Y max divided by I. Now M max that I given, and this is your M max. Sorry, this is your M max. Y max would be 150 divided by 2, and your I has already I given. So please solve it. I am writing the value. Sigma maximum is equal to 40 megapascal. So anyone have any problem, please ask. Hello. If not, then I am going ahead. If I have any problem, then ask. Now for the same cross section, I can change the I. Now let me give you in more general way, not a particular question. Suppose the parameters are sigma is equal to my by I. So if it is said that you need to find the maximum, so draw the bending moment diagram. So the steps to solve bending stress problem is, write it in your copy. Bending stress problem is maximum bending stress problem or whatever location. First, draw bending moment diagram. Draw bending moment diagram. Obtain the location. Obtain the location and corresponding bending moment. What is the value of bending moment at that location? Suppose in the earlier problem, I haven't asked find the, suppose in this problem, I haven't said to find the maximum bending stress. I said that find the bending stress at this point. What would be the value of that, or at this point, in this point? So you need to first draw the bending moment diagram and obtain the location and bending moment. Then obtained y. Suppose they are not always at the top. It can lie in between. So obtained y, then equate sigma at desired location. Desired means where it is asked, at desired location. In 2000 in gate 2021, they given a problem, and it is given that obtain the bending stress at the maximum, or I can say obtain the maximum bending stress. In gate 2021 they asked. So I hope now everyone getting it. So now the another thing that I can change is I. So you need to be very cautious about I. So for a square, for a rectangle, now for a hollow square, what will the value of I? For a hollow square, it will be 1 by 12. It is, you can say, you can subtract the two things, b cube, or sorry, if it is b, it is d, it should be um, d d cube upon 12 minus small d cube by 12. If it is a hollow circle, then its value is pi by 64 d raised to the power 4 minus small d raised to the power 4. If it is a triangle, that I already said, it is b h cube by 36. Okay. Now these are all the things that you need to understand. Uh, Now I hope normal bending stresses is clear. Now the concept of what it is given, combined and bending stresses. So I am giving you 10 minutes. Okay. Uh, just you go and take a 10-minute break. Then I am coming back. So is it okay?
Yes, sir.
Okay. I hope everyone is sleeping because a long class. Guessing that. Okay. After 10 minutes. So now the question is, earlier I discussed that it is acting, the the body is acting with only bending. So only bending. Now I am going with the bending and direct stress. Means you can say that direct combination of direct load that creates tensile stress, as well as bending moment that also creates tensile stress. So now I will add this case. Suppose I just discussed. Suppose this is a body and it is loaded by the P at its neutral axis. So the compressive force will act. You know the area of cross section is A. Then your compressive force is sigma is equal to P by A. Now uh, it is given that I will act load like this. This is your neutral axis, and I will act load somewhere at distance E. Now, the condition is now a little bit tricky because now you can see that this part is getting more stressed and this part is getting less stressed. General assumptions, I'm not going in mathematical, just from simple intuition of yours, you can see that this part is getting more stress and this part is getting less stress. From this, you can see that the stress can be evenly distributed, but here it is not. So what should I do? So just like I said, okay, let's draw it, and this load is acting, which is P. Now add another load P here and in the opposite direction. Now what will this cause? This will not change any configuration of the given system. Means the P load is acting here, so now the P load is also acting here, and this will subtract. Now you can see that Because of this eccentricity, this is forming a couple, and you can this system is equivalent to a load P and a couple PE acting on the body. This is a couple. Now, from this configuration, you can see that this body at the center has two loads, and it is acting compressive in nature, and it is also just trying to means this portion has a couple at clockwise moment that will tend to compress this part and elongate this part. If you can see that. Now, that means this system can be considered as a load is acting and a couple is acting at the center plus. Now you can apply principle of superposition. Principle of superposition. That means for this you can note sigma is equal to P by A. That is uniform, means if I consider this surface, this is uniform about this surface whole. Now if I consider this moment, now the moment would be uh, suppose this is D and this is B. Now you can see that this is the distance from the top fiber. So if you write sigma bending, it will be suppose the couple that is PE into the maximum distance that is B by 2 from the neutral line. This is the your neutral line and this is your maximum distance. And add from this at this neutral line, what is I? I is B cube H B cube D by 12. Okay. So you got sigma compressive that is PE, sorry, P by A, and you got sigma bending that is PE into B by 2 divided by B cube D by 12. Now this is normal stress and this is normal stress. So you can add them, okay? Because I just taught you in a peer class, not like stresses can be simply added and subtracted. So you can add them. Sigma max would be sigma C plus sigma B, and sigma minimum will be sigma C minus sigma B. Now why I written this way? Uh, just I'm going to explain it. Suppose this is your body and you are applying P load here. So the whole section is in compression. So you can see that suppose this is your reference line. So this is a stress diagram. The whole section is in compression. Is they are resisting like this. Now if I just draw a couple like this, then this bottom portion is elongating and this bottom portion is compressing. So that will be equal to, this is in compression but this is in tension, okay, and it will like this. So if you sum up this, you can get that this is tension and this is compression. So the compressive, because compressive is negative, here compressive is negative and this is positive. So here you got minimum stress, and that is sigma compressive minus sigma bending, and bending is tensile. Here the bending is tensile, but here in this point, at this point, you are getting sigma compressive plus sigma bending. Okay, because both are compressive in this phase. But here, because of the bending, this portion is tensile and this portion is compressive. I hope everyone is getting what I trying to say. Hello. Okay, I am explaining you through a question. Suppose it is given a load this is a not neutral axis. A load is acting 180 kilonewton. Eccentricity is 10 mm, means this distance is 10 mm. You are given this height and length. Sorry, you can say this is the width, this is the height, and if you see from the upside, means up from up, it will be like this, and the cross sections are 150 by 120. So you need to find what is the maximum and minimum stresses. So means you can say it like this. I want to draw it in 3D so that you can get what I want to say. Suppose this is like this, a vertical beam you can say. Okay, and this is your neutral plane. And at this point, a load is acting P, that is at some distance E. And this is your cross section that is given here. And this is your that means this is your length. So you need to find what is the maximum bending stress. This is called strut. Okay, it is called strut. So you need to find maximum and minimum stresses. So first of all, if you just uh, trans uh, convert it to the system that I explained earlier, this portion will be like this. The length would be like this, P and a couple, and the couple is equal to P into E. That is equal to 180 into 10 into 10 to the power 3 because it is kilonewton. This is the couple. Now sigma compressive is equal to 180 into 10 to the power 3 divided by 150 into 120. Sigma bending is equal to PE into h by 2. What is h? Means if you see the distance, this distance is 150 divided by 2. That is 75. Okay. Now it is 75 divided by I. I would be what I would take 150 raised to the power 3 into 120 divided by 12. Okay. Okay. Now what is the minimum stress? Minimum stress would be sigma c minus sigma b, and maximum stress would be sigma c plus sigma b. I, is there any doubt in this problem? Hello. This is a simple question, just transforming the stress, just transforming the force into a direct force and a couple. So this is called combined loading, means direct load is acting and a bending stress is acting. Now because both are alike, you can directly add them, subtract them. Now bending stress generate compression and tension at the both surfaces. So if and the direct load is generating either compression or tension. So you can simply say that I will tend to rotate it. I will tend to add the system. So in one plane it is compressive and the bending stress is tensile. In other plane it is tensile, it is compressive, and the bending stress is also compressive. So please write in chat box if you understand, or I will explain one time more. Can you write in the chat box? Hello. Okay, I got one message. Okay, now I'm going with the next concept, that is beams of unsymmetrical sections. Now, as you know, I hope you have seen what is the shape of the railway track. that is the I section. Okay, they are not putting tracks like if you see this is your track, this is your whole length of the track, and if you see from this if you see from this section, it is like I. Now why they made it like I section? Because the main reason for this is uh, the more distance because it increases the m sorry I. I hope you know I is equal to m sigma of m r square mri. This is your I. So if the mass is distributed away from the center, then it will be good. It will increase the I. Now sigma is equal to my by I. For a given moment, if you decrease the I, the bending stress will decrease. And if bending stress will decrease, then this will be below the allowable limit. Okay? Means why we want to increase the I? So that we decrease the bending stress. And if we decrease the bending stress, the life of the material would be longer. That's why we want to increase the I. So this is the unsymmetrical sections. Suppose this section, this is also unsymmetrical sections. So anything like that would would come in unsymmetrical sections, and we have to obtain the maximum bending stress and the minimum bending stress. So suppose you want to design the dimensions of a railway track. You want to design what should be the height, what should be the b, what should. So you need to manage how these things are acting. So you need to find out the maximum bending stress, minimum bending stress to find the dimensions of the body. Okay. So let me give you a hint. Difference between what we study in SOM, we are given dimensions and we find that what is the sigma stresses we obtained. Means the things that is given is dimensions and we obtain the stresses. But in machine design, we have given stresses and we need to find the dimensions. Okay. Now, what is the meaning of this? This is the this is given point and this is the finding in SOM. Okay. Now in machine design, this is given and you need to find. So that's what is called designing. Designing means obtaining the dimensions and so means analysis. Just like you can say in means you can say that you are given the dimensions, obtain the stresses. Now here you are given the stresses, obtain the dimensions. Okay, that is the basic difference. So let me go with the I section. Sorry, T section. Suppose this is the T section. So here, okay. Now, as you know, first of all, you know the formula my by I. You can obtain m from the load acting. Suppose this is your bar and its section string from here is T. Okay. Now you can obtain y also because suppose you are given some neutral plane. You can obtain the distance y. You can obtain I about the neutral plane. But in T section, you cannot just say, okay, the y is here in the bottom or in the top. You need to find, and you all know neutral plane should coincide with center of gravity. So I hope in mechanics we obtain center of gravity. That suppose this is the center of gravity from this rectangular part and this is center of gravity for this rectangular part. So if suppose from the distance I am obtaining from the bottom, this is y1 and this is y2. So y bar is equal to m1 or sorry a1 y1 plus a2 y2 upon a1 plus a2. I hope everyone has learned this. So from that we can obtain the distance. Suppose this is the distance. This is your y bar. Okay, you obtain that, and this is the axis of a neutral plane. Now at this point, you need to obtain what is the moment of inertia. So suppose this is your center of gravity for this rectangular part. and it is y bar from y bar at the above. So what, first of all, for the first part obtained, it will be b d cube by 12. Okay, now shift the axis to the up, and that will be area times y bar minus y1 whole square plus the top portion. Top portion has a moment of inertia about this axis is, it is also b d cube by 12. Now shift the axis to bottom at the neutral plane. So this is, suppose this is y2, given y2, y2 minus yp, y2 minus yp, sorry, y bar square into a2. This is the way you obtain the moment of inertia, MOI, okay, or I simply you can say. This is the moment of inertia of this section. I am just revising you. I hope you all studied in mechanics. So how you obtain? Now I am giving you a question. Just try to obtain it for the T section. This will not come exams very frequently, but you need to know how to solve this. Okay, okay, this is T section. Sorry for the drawing. This is 150 mm. This is 50 mm. This flange. This is again 150 mm, and what, this is 50 mm. Now you need to find the y bar. First find y bar, then find moment of inertia about that y bar. So for bending stress, you need to know this sigma b. For this, you need to find m y by I. So you are given m, you have to find y and I. So I am asking you to find these two things. Okay. I am giving you 1 minute. Think about it. I will solve later. Think about it. Okay, I'm going with. So suppose uh, I'm obtaining it from here, from the bottom. Okay, so for this flange, this section, this is around 75 mm from bottom. Okay, and this is the center. This is the means center of gravity for the top portion. And what is the distance? This is 150 and this is 25. It is 175. Okay, 175. And the area, area of, suppose this is portion A2, area is 150 into 50, and this area is A1 is equal to 150 into 50. Now y bar is equal to, from the base, 75 into 150 into 50 plus 175 into 150 into 50 divided by 2 times 150 into 50, because both are of same area. So if you solve this, you are getting the y bar as 125 mm from the base. Means from the base it is 125 mm. Means somewhere here y bar is 125 mm. Now you have to obtain, this is your neutral plane. Now this is because center of gravity, this is the neutral plane of the body. You have to find I about the neutral plane. Okay. So first, how I will solve this? Uh, If you solve this, suppose it is you can this for this section, you can obtain the neutral plane as 150 raised to the power 3 into 50 divided by 12. Now shift the plane. You know shifting property in mechanics in moment of inertia theorem 1. 50 into 150 into this is 125, this is 75. Then what is the difference? 50 I think into 50 square plus the second one is 50 cube into 150 divided by 12 plus what is the difference? So this is 125 and this is 175. So the difference again is 50. 50 into 150 into 50 square. I hope everyone is getting it. So the moment of inertia about the neutral plane is coming 53.125 into 10 raised to the power 6 meter mm cube power 4. This is I about the neutral plane. Okay. Now, as you obtain the neutral plane, so the maximum stress. This is the neutral plane. I about the neutral plane. Now you know m means moment. Suppose it is given something. Okay. It is given 6.4 kilonewton meter. Now what is the y? Now y from here is at two portion. This is at top, at bottom. Okay, at top it is suppose this is distance y2 and at bottom this is distance y1. So what is the this is portion A, this is portion B. Wait a sec. Okay, now sigma at 1, sorry, sigma at A is equal to m, it is given 6.4 into 10 raised to power 3 into 10 raised to power 3, that is Newton mm. Then into y, what is the distance of y2? Divided by I, 53.125 into 10 raised to the power 6. Sigma at B, that is 6.4 into 10 raised to the power 3 into 10 raised to the power 3 into y1 divided by 53.125 into 10 raised to the power 6. Now, you can see that sigma A is coming 15.06 megapascal and sigma B is coming 9.04 megapascal. And this so what is the meaning of this? Means as you can see in symmetric sections both are equal, but here you can see because the neutral plane has shifted upwards, the distance is reduced, but the means you can see the distance is reduced. uh, I'm looking something upper extreme fiber. Okay, now it is total, it is 150 for the 200 and it is 125. 225. Sorry, this will be yeah, okay. Sigma B and sigma I means the sigma is at the bottom portion. No, it is given. Moment is given. Not I'm not saying it is I am calculating. It is given 6.4 kilonewton meter. Okay. How much I calculate? I need to take something now because I want to explain I how to find I, how to find Y. Okay. So for unsymmetrical problems, suppose the T section is given. Okay. Now someone say let me write it. Now, suppose it is given I section. Okay, then you need to find y, again y bar, because there are three sections 1, 2 and 3. Then you again need to find I about the neutral. Suppose this is your neutral because Sometimes this symmetry came, and this will be at the bottom, at the center point. The top area and the bottom area is same, so it will come at the center point. But you need to find I. Then you need to find I. Then sigma will be my by I. So the distance from the top fiber, the distance from the bottom fiber, you need to find. So this is a long question. Means there doesn't came in GATE exam, but you need to know how the process, because sometimes if they can directly give I, okay, then you need to find Y. You need to find Y now. And how you obtained Y? By obtaining the Y bar. When you obtain the Y bar, you can subtract the distance, you can get Y1, you can get Y2. So you need the process to know, to be known. Otherwise, you will get what to do in the exam. Now, beams of unsymmetrical strength. Now, I will go with beams of uniform strength. What is the meaning of uniform strength? So, as you have seen, sigma is equal to my by I. As y increases, sigma increases. Okay. Suppose this is your beam and this is your rectangular section. Now, if you see at the top there is a maximum bending stress. At the center it is 0 because y is equal to 0 at the neutral plane. And at the bottom it is compressive. Hello. Okay. So as you can see, if you want to design for the suppose you want to design, you want to obtain the dimension of the beam, then you take maximum stress as consideration. But maximum stress is not uniform all over the plane, all over the body. Means suppose the upper fiber is at risk, you want to design. Now you make this beam on the risk of upper fiber. That is the wastage of material now, because other than the upper fiber the stress is below the means material failure limit. So this is the wastage of material. So I hope you have seen flyovers in your city. Flyover doesn't suppose this is your flyover. They doesn't make uniform. You can see that this is sometimes this shape. Okay, they made this shape. Okay. Sometimes they made with two columns, one column here, one column here, and they made this way. This is not uniform. Means why this is not uniform? Because sigma max is at the upper fibers only, other than it is below. But if you design the beam for the sigma max, then the whole body will design at according to sigma max, but it is not required. So your the regular cross section will not be helpful in that. So for that you need to find uh, you need to find the relation. Sometimes they ask what is the width varying with length, what is the height varying with length. Okay, for that you need to obtain. Suppose, so I'm giving you I'm just suppose your beam is given. Okay, and the cross sections are not like that. Means they are sorry, it should be like this. And the cross section is here 60 by 60, and here 180 by 60, and the length is 3 meters, and a load is acting 4 kilonewton. So you need to find the maximum means what is the stress at maximum stresses acting at the point. What is the maximum bending stress induced? Okay. So as you know, the cross sections are not uniform now. So you need to find I at every point. Okay. So let me go with suppose I take X distance, and this is varying, the dimensions are varying linearly. One thing, 160 is constant, but other sorry, this 60 is variable and this 60 is constant. Means the width is constant, the height is variable. So you need to obtain the as of I as a function of X, and also y as a function of x. Okay, and m is also a function of x. So three functions of x, then you obtain bending stress, then differentiate it with respect to x to obtain the equation. Okay, so first of all, 4 kilonewton is acting. So at the x distance, what is the moment? It is 4 into 10 raised to the power 3 into x. Okay, so and if x is a meter, it is 10 to the power 6. So sorry, 4 into 10 to the power 6 x Newton mm. This is your moment as a function of x. Now you need to find y, you need to find I. Now I want to, before going to that, I want to ask you, this is your equation, and if I put it like this, I by y, this is called the section modulus. Okay, this is called section modulus in bending stress. So sigma is equal to m by z. It is represented by z, and it is called section modulus. So for square, okay, this is h, this is b. So I is h cube b by 12. Okay, just one sec, I'm coming. Just one sec. Hello. So okay, I'm so here we need to find section modulus. So I'm asking about the section modulus. So s cube by b by 12, and your y is equal to h by 2. So what is the section modulus for this? H cube b by 12 divided by h by 2. So it will be h square b by 6. Okay. Now same for the circle also you can obtain. Same for the triangle also you can obtain. Now individually finding y and I state yes. Just obtain z as h square b by 6. So you can see that is b is constant, only h is varying. So what is we need to find h as a function. So it is 60. Here it is given 60, it is given 180. So at x is equal to, means the function of h as a function of x is equal to it is like 60 plus 180 minus 60 divided by 3 into x. That is equal to 60 plus 40x. This is h. Okay. Now, okay. Then what is then bending stress as a function of x is equal to 4 into 10 to the power 6 x into what is the value of y? Oh, sorry, y I just cancelled with the that term, so it will not come. Divided by I. I is h square b by 6 and h is 60 plus 40x whole square into 60 divided by 6. So it will 6 will come go. So it is 24 into 10 raised to the power 6 x upon 60 plus 40x whole square into 60. So you can see that bending stress obtained is a function of x. So for the maximum bending stress, you can just differentiate it with respect to 0, and you can obtain the distance of s. and the distance of x is coming 1.5 meter. Okay, I am just leaving it to you, you can differentiate it. And at that point, the maximum bending stress is obtained. You can, that will be 41.7 megapascal. So I hope there is some confusion with the students because this is a quite complex thing. So I'm trying to explain it in here again. So the question that is given is, it is not uniform. It is just changing the height. The height is changing. The width is constant, the height is changing. Here it is 180, here it is 60. And take some distance, arbitrary distance x. So obtain sigma x as a function of my by I or m by z, section modulus, in terms of section modulus. So m is, the load is given, that is 4 kilonewton. So 4 into 10 raised to the power 6 into h, okay, in mm, Newton mm. Now, what is the value of z? Z is equal to h square b by 6, and h is a function of x, that is h is equal to 60 plus 40x. And from the end, if you put x is equal to 0, it is coming 60, and from at x is equal to 3, it is coming 180. Now, put that value, obtain sigma b, sigma as a function of x, and that comes 4 into 10 to the power 6 x upon 60 plus 40x whole square into b divided by into 6. Now this is function of x. For maxima and minima, you know that you need to differentiate x with respect to sigma with respect to s and equate it to the 0. You obtain the location that is equal to 1.5 meter from this end where the maximum bending stress is occurring, and add put this value in sigma, you can obtain the maximum bending stress. Hello, I hope everything is clear to you. If there is any problem, you can ask. Or are you with me up to this point? Please message me. Just write something if you want. Hello, can anyone say I should move ahead? Tell something so that I move ahead. Okay, I'm not getting any replies, so I'm moving ahead. Now, steering stresses and beams. So before that, I discussed the bending stress, and in bending stress, I discussed pure bending. Pure bending means there is no any shear stress, no any shear force. So, but in actual cases, shear force are there. So shear force is there, then there is also shear stress. So suppose you have a body, and at this point you have a couple acting moment m, and at this point you have m plus tm. Okay, now the moment is changing, so the bending stress is changing, and bending stress is changing means the bending force is changing. Hence, you need to maintain a force that will oppose the change, and that is called the shear stress. That is called the shear stress. Okay, the shear stress occurs when there is change in bending moment. If bending moment doesn't change, then the shear force will not occur. It will equal to 0. Hence, a relation has been derived that shear force SF is equal to dm by dx. Okay, better to yeah, remember it, that shear force is equal to dm by dx. If m is not changing, then dm by dx derivative of m with respect to s is 0. That means shear force is 0 in the body. But if it is m is changing, that dm by dx, okay, there is there, and that is equal to the shear force in the body, and shear force lead to shear stress. Okay, so now suppose I'm writing the equation. shear force in regular sections. Okay, just the equation, you don't need to derive, but remember the equation. Thus, shear stress is equal to F into A into Y bar upon IB. Just like in sigma by Y is equal to M by I is equal to E by R, I discussed every term. I will discuss these terms also. First of all, this is shear stress in the beam. Shear stress in beams. This is your shear force at that location. For that, at that location, you obtain the bending moment. At that location, obtain the shear force. This is the area of the elemental strip which you want to obtain. Elemental strip. Y bar, distance of that elemental strip from the neutral plane. Okay, simply I here both are same, and it B is the width. B is the width. So this is the shear stress formula. F into A into Y bar upon IB. In beams, shear stress formula is also F by A, but this is general case, means something is acting directly, but this is for beams. Okay, so I'm going to elaborate one or two points. It's just like for rectangular sections. So suppose this is a rectangular section, okay, and this is your neutral plane. This is y is equal to 0. And I am taking an elemental strip. Suppose this is my elemental strip, and I want to obtain the shear stress at this portion. Shear stress. So suppose this is a distance y from here. Okay. Then so what will be the means if I take at the if I take at the top, it must be okay. Suppose this is a section. Suppose I am taking at the top. Okay, y is y distance. So this is d by 2, whole is d by 2, and this is at the y. So what is the thickness of this? This is d by 2 minus y. Okay, now this is the d is the width. So what is the area? That area I'm talking about, the area of the strip. This area is d by 2 minus y times b. Okay, and now what is y? The centroid with the bottom axis. So suppose this is y. Okay, now y bar is equal to y plus width by 2. Okay, means this is the width after half. This is the y bar from the base plane. So it will be equal to d by 2 plus y by 2. Okay, y bar. Now shear force at that point is F. Suppose the shear force at that point is F. So shear stress will be F into area is d by 2 minus y times b into y bar. That is d by 2 plus y by 2 upon I. That is equal to F by 2i. Okay, d square by 4 minus y square. So as you increase y, and if y is equal to d by 2, it is d by 2, shear stress is 0. That means you can see that this is following a parabolic path because it is function of y square. Okay, it is following parabolic. The equation, the shear stress is a function of y and it is parabolic. And if you consider the bending stress is linear and its sense is maximum at the extremes and 0 at the center. But here at the center it is maximum and at the ends it is minimum. So shear stress is maximum at center and 0 at other extremes. That is opposite to bending stress. Okay, that is opposite to bending stress. So, say this is for the rectangular sections. Now, what is the maximum bending stress in rectangular section? Maximum bending stress, if we put y is equal to 0, it is f by 2y into d square by 4. Okay. Now, if I put I is equal to b d cube by 12, then it will come 3f by 2 bd. And you know b into d is area. So it is 1.5 times tau average. Tau average means f by bd is the shear stress average. So that means tau max is equal to 1.5 times tau average. Now for the same case, if I consider, so I'm writing it directly. Okay, I derived it for square, now a rectangle, now for circle and for triangle. Here tau maximum is equal to, for a circle, tau maximum is equal to 1.33 tau average, and here tau maximum is equal to, I think 1.5. Yeah, it is 1.5 tau average. Okay, and it is at h by 2, and therefore that means for a triangle, this is your median. Okay, this is h by 2, this is h by 3, 2h by 3, this is 2h by 3, and this is h by 2. Now, but at 2h by 3, tau is equal to 1.33 tau average. So please remember this relation and this formula directly. Otherwise, they will ask directly from this relations only. This is for symmetrical sections. Okay. Now in unsymmetrical sections, I'm just not going with the derivation because they will not ask very much, but I will just give you the glimpse. I didn't even remember when they last time asked with the unsymmetrical sections gate problem. They don't only ask the diagrams. So in that portion, if you just take the y as y is equal to 0 as neutral plane. Okay. Now this is the upper flange. This is the lower flange. Flange. This is called the and this is the web. Okay. So in this, what is the shear force diagram? What is shear force diagram around the whole body? So first of all, you need to first take this area, then you need to take this area, then you need to take this area and draw the figure. So it is very big problem. Suppose I take this d by 2 and take this as capital D by 2. This is capital B, this is small b. Now suppose if I am taking the upper flange, okay, if I take in the upper flange, so what is the area? Area would be d by 2 minus y into d. Okay. Now, what is y bar? Y bar is equal to d by 2 plus y divided by 2 from the earlier case. So, what is the shear stress? Shear stress is f by 2y d square by 4 minus y square d by 4 by 2y into y square. Okay. Now, what if I came in between? Suppose I came here. Okay. Now, what will be the change? The change is the capital D will change to small d. Then the tau is equal to f by 2y. Uh, that will be a complex thing because now the distance will be changed. I need to take the whole. I need to take this much area, whole area from the top. So I am writing means I cannot write directly, otherwise you will get confused. Okay. So let me try to like a whole. Suppose if I am taking this and this is your area, and I want to obtain, and this is your center y is equal to 0, and this is your y. Now what is the area? The area would be now uh, b into this, b this is a b into d by 2, b into d by 2 plus this is suppose this is y, and this is small d by 2 plus small b into d by 2 minus y. This is your area for this section. Okay. Now what is the y bar? Y bar is equal to, you need to find y bar of this section. So for this here y bar, for this here y bar, so it will be in between. So you need to find that y bar and then subtract it from this. So it is a little complex one. So I'm not going with this. I'm going directly with the stress diagram. So, but I think you know how the shear stress are going. So I'm directly drawing it. So suppose this is your I section. So in this case, so just I explained before, the for the rectangle it is parabolic. So if I take this as a line and I draw, it is like parabolic. Okay. Now at this junction, shear stress is same. Means shear force is same, but stresses are different. They group. Shear force is same. That means sigma tau 1 into a1 is equal to tau 2 into a2. Now the area here is large and here the area is small. So if you just click it, it will be like area into b1, sorry, capital. It is not area because the term, another term will cancel out from the bottom. So from bottom I, so it will be tau 1 into b1 is equal to tau 2 into small b2 b1. So as you know that this thing is decreased and this one is large. So at this point, if you know this tau 1, you know b1, then just divide it by, so it will increase suddenly at the junctions. Then again rectangular section, parabolic, then at this point again the the length is increased, so it will come down and then again follow the same parabolic path. I hope you are getting it, because these are the things only asked. They do not ask the value. Okay. Now for the T sections, I am going to draw with it for the T sections. Suppose this is a T section. Now, if you draw this the shear stress diagram, here it is again rectangular, so parabolic. Then there is again the area reduced suddenly, so there is a jump. And at this point, if this is here is tau 1 b1 tau 2 b2, then it is equal to tau 1 b1 is equal to tau 2 b2. Therefore, the shear stress as 2 is equal to tau 1 b1 by b2. So here you get again a increase, and then it will again parabolic, and extreme it will be 0. Okay. So this is from the symmetrical shearing stresses in beams. So at this point, I hope shearing stress is not very clear for unsymmetrical sections, but you need to remember this formula for shearing stress in beams, because they will ask directly. So just like they ask you what is the in triangle maximum shear stress occurs at the maximum shear stress occurs at h by 2, not 2h by 3. Okay, so for triangular cross sections, they will ask like that, or Means in and they can ask, suppose in inverted T sections, suppose this is T section, they can ask in inverted T sections the bending stress will be maximum. So at the junction of the two, the maximum will occur most of the time. Hello. Now, can anyone have questions? Hello. Please unmute yourself. Ask anything.
Sir,
Yes. Yes. Please speak. Okay. I'm going to give you a means of two problems. Okay. Just from bending stresses and shear stresses, because I have to end it by one. And also I want to say that at 1:30 you need to come again. I hope you got the link. Okay. I hope you got the
yes, sir.
link. Okay.
Not 2:30, yes, sir. It's not 2:30.
Yeah, it is 1:30. I think
1:32 till which time, sir?
three
Till
means I will leave you at one. Okay. Then you need to return at 1:30, and up to 3 we will take the class.
you will take the class. Okay, sir.
I hope you understand. You got